Assalamualaikum warahmatullahi wabarakatuh. Let me introduce our group. It consists of Firsyaldo Rizky Purnomo, me, Ondang Fajrul Falach, and Imam Rosadi. And now I will explain a 16 control system. Chapter 1, Introduction. PID control have a simple structure so they are easy to implement. In PID control, fault signals are used to generate control signals, namely a combination of proportional control action, integral control action, and derivative control action from Henry Budi Santoso 2018. Transfer function to a system in the industry must be parsed in such a way so that the desired result are achieved, i.e., go beyond the small offshoot by modifying the PID component. Industrial motor speed control by using PID can be optimized by producing varied P, I, and D price. The determinants of the value of PID parameter is done by analytical methods in the design of the setup system. The spinal speed is expressed in rad per second units so that the function is switch or transfer function. It is accepted that in the use of PID controls can control industrial machine to produce small overshoot so that the system on industrial machinery remains stable. Chapter 2, Methodology 2.1 PID. Based on the survey, 97% of industry engaged in the process such as chemical, pulp, food, oil, and gas industries use PID as the main component in their control. For example, for a particular process model, changing the Kp value magnified or reduced would generally require resetting the Ki or It and Kd or Td control parameter. The table below shows how each PID parameter change in the general process control performance. That's all for me Ondang, and then next slide will explain from my friend.
Okay, I want to continue about explanation from Ondang Fajrul Falach. The table below show how each PID parameter change in the general process control performance. If you want to see that table, you can pause to catch this point. So next, there are 6-point PID control structure and tuning methods. If you want to catch this point, you can pause this video. 2.2 Auto-tuning. Auto-tuning methods that can be used. There are two methods commonly found in PID control module. Number one is transit response methods and two relay feedback methods.
Okay, my name is Firsyaldo Rizky Purnomo. In this chapter, I will discuss and analyze the result of the simulation that we have previously made with the parameter specified previously. Okay, I used the MATLAB program to simulate a mathematical model on a DC motors system which will be represented in the simulation. This is the graph is the non-PID and is using PID. Okay, we can go to slideshow. Yes, this is a model design of the MATLAB of non-PID is here is using PID. Okay, here is the model design. Okay, I apologize to shorten the time, so I will briefly explain the P, PI, and PD control for the P control analysis. Okay, I'm very apologize for the time. Okay, it's control analysis in this one of figure of P controller. Okay, this is one of the analysis. P controller are increase or decrease stability, can improve transient response, in particular rise time, settling time, reduce, not eliminate steady state error. To eliminate steady state error, a large Kp is needed, which will make the system more unstable. Proportional controllers have a direct effect on error. The greater the control signal generated by the controller. This is a sinusoidal wave of the P control. Okay, next we will go to in the PI controller. This is a graphic of PI controller. The analysis is eliminates error steady state. Slower response compared to P can cause instability due to increasing the error. Change in control signal proportional to change in error. The bigger the error, the faster the control signal increase or change. This is a graphic, is a very constant, but it's not reach the steady state error. Okay, because we need the PID control. Okay, P next we go to the controller the next controller is here's a PD controller, and this is described as PD controller, and the analysis is provides a damping effect on an oscillating system so that it can increase the value of KP, improve transient response, because it provides an agent when there is a change in error. T only change when there is a change in error. So when there is a static error, T does not act, so that T cannot be used alone. The size of the control signal is proportional with the change of error. The faster the error change, the greater of the control action the graph radius. Okay, next we will go to finally in this chapter is a PID control and comparing non-using PID with using PID. Okay, I will try demonstrate how the PID control works and how can I get the settling time, overshoot, and peak time values. Okay, we will go to in the interface of the MATLAB. This is my coding for the simulation of design, and then we go to design. Yes, we go to the design. Okay, this is a design model that I explained earlier. This is there is a PID control. There is a function of DC system motor DC, and this the output. Okay, then we for the way there is know with how to make the setting time, rest time. We when click and we must be know the graphic. Okay, for manually tune, I find the value P equal 0, I equal -2, and derivative or T equal 0. This is a manual tune. Okay. We will compare the manual tune and the auto tune. How it is? We click tune. Linear plan. Okay, we will compare the manual tune and the automatic result. On the block lines, this is graphic of PID control. On the block line is the result of being manually tuned. This is a block line. This is a block response. And then the tune response or tune line is the result of being auto-tuned. This is a compare. And how I can get the value of setting time, overshoot, and we can click the show parameter. That's it. This is interface of that of tune or manual tune. We can get rest time 3.48 seconds, and block we can get here. You can see here. Okay, and then we go to the PowerPoint, and then this is the comparing graphic when the system using PID and the system non-using PID. This is a using PID. I'm apologize. This is a non-using PID, and this is a using PID. Okay, thank you. My teammate will explain it. Wassalamualaikum warahmatullahi wabarakatuh.
In this part is conclusion. Number 1, PD control influence on the system. Number 2, PI controlling the effect on the system on both Fig 4 and Fig Crabs 5. Number 3, PIC controlling the effect on the system on both the Fig 4 and the Fig 5. Number 4 is the advantage of PID controller according to the graphs and analysis combining the advantage of PI and D controller. Q is improved transient response. I eliminated steady state error, and D provides a damping effect. So that's enough for me. Thanks.